Good morning, students. Students, I hope you must have seen the last virtual video in which I discussed the assignment problems, and the concept of laws of chemical combination must have been very clear to you. Now students, today we start our discussion with the discussion of Dalton's atomic theory. The Dalton's atomic theory was discussed with you in the class 8th basically. So very quickly I will recapitulate all the points of a Dalton's atomic theory and move ahead with this chapter. Now the Dalton's atomic theory. Who presented this theory? Dalton. What are the main points of the theory? Just to save the time, I have written the points of the Dalton's atomic theory on board so that you can easily note down also. What is the first point of the theory? Matter is made up of extremely small indivisible particle which is called as a atom. Am I clear? So first point of the theory is matter is made up of the small indivisible particle called as a atom. Then atom of same element, they are same in all aspect. I mean to say they have a same mass and the same size. You remember these points. Then atoms of a different element have different mass. They may also have a different size. Am I clear? So matter is made up of extremely small indivisible particle called as atom. Atom of same element are same in all aspect. Atom of a different element may have a different mass. Then atom cannot be created, destroyed or transformed as per Dalton. Atom retain their identity in a chemical reaction. And then when atoms combine with each other, they combine in the simple ratio to form the compounds. Now this theory was very soon modified and is being given as a modification of a Dalton's atomic theory. What are the main points which are modified in the Dalton's atomic theory? According to the Daltons, atoms of a same element are same in all aspects. But according to the modified atomic theory, there occurs isotopes. Isotopes are the atoms of the same element which have the same mass but different atomic number. Then atoms of a different element have different mass. But then according to the modern atomic theory, there are isobars. These are the atoms of a different element which have a same mass but different atomic number. So the isotopes and isobar are the modification of these points of our Dalton's atomic theory. According to the Dalton's atomic theory, atoms of a same element always have a same mass, but atoms of a same element are same in all aspects, that is have a same mass. But according to the modern theory, there occurs the isotopes in which the atoms are of the same element with the same atomic number but different atomic mass. As for example, if I say, we say 6C12 and then 6C13, you may see they are carbon atoms. But here the mass of a carbon is 12 and here the mass of a carbon is 13. So the modification of this theory says that there will be the formation of isotopes, and isotopes are the atoms of the same element with same atomic number but different atomic mass. Then Dalton says that, so isotopes are the modification of the Dalton's atomic theory. Then the Dalton says that atoms of a different element have different mass, but according to the modern theory, there occurs the isobars. Isobars are the atoms of different element. They are the different element but with same mass number. As for example, we take 19 potassium 40 and then we take 20 calcium 40. You may see over here, these are the atoms of different element but the mass number is same. Is it clear? Their atomic number is different but the mass number over here will be same. So these are called as isobars. So isotopes are the atoms of same element with same atomic number but different mass number. Isobars are the atoms of different element with different atomic number but same atomic mass. So modification is clear. Then there is one more point. according to Dalton's atomic theory, atom cannot be created, destroyed or transformed. But according to the modern theory, there is a complete science of a radioactivity. Yes, and what is radioactivity? In which the atoms are transformed from one atom to another. Am I clear? So, entire concept of a science of a radioactivity is against this point of a Dalton's atomic theory. Here, the transformation of an atom may take place. Is it clear or not over here, student? Then, atom retain their identity in the chemical reaction, agreed. This says atom combine with each other in a simple ratio to form a compound. According to the modern theory, atoms may also combine in the complex ratio to form the compounds. It's not a necessity that they combine in the simple ratio to form a compound. They may combine in the complex ratio also to form the compound. We may take the compound like chlorophyll. We may take the compound like hemoglobin. There are large number of atoms of various elements which are combining with each other. Definitely that is not a simple ratio. So this is a modified form of our Dalton's atomic theory. I have not written the points over here, the modified forms of our Dalton's atomic theory, but the points are given in the book prescribed to you. But to let you recapitulate the thing, I have tried to explain to you what do I mean by the Dalton's atomic theory. So what are the main point? Matter is made up of an extremely small indivisible particle called atom. Atoms of same element are same in all aspects, but modified theory says that there occurs the isotopes. Then atoms of a different element have a different mass. Modified theory says that there occurs the isobars. Then atom cannot be created, destroyed or transformed, but there is a nuclear transformation in the concept of a radioactivity. Then atoms combine with each other in the simple ratio to form a compound. Modified theory says that atoms may combine in the complex ratio to form a compound. Am I clear over here? So atoms may combine in the complex ratio to form a compound. Now, what have we studied in this chapter? First of all, we introduced brief classification, then we discussed the measurements in the chemistry, then the significant figures, and then we discussed with you the definition of element, compound and mixture, and then we discussed the laws of various chemical combination. Then today we have started our discussion with Dalton's atomic theory. The various laws that we discussed with you was the law of conservation of mass, then the law of constant proportion, law of multiple proportion, law of reciprocal proportion, and the Gay-Lussac's law of a combining volume. Then today we have discussed with you what do we mean or what are the main postulates of the Dalton's atomic theory. Students, there are three words in chemistry: atoms, molecules and formula. What is the difference between atom and molecule? Atoms do not exist independently in the nature, whereas the molecules may exist independently in the nature. Fine. Compounds are formed by the combination of various atoms. Now, we will be discussing with you the atomic mass. What do we mean by atomic mass? Or, in fact, the right word will be relative atomic mass. So, relative atomic mass. In short, it is written as RAM. What is relative atomic mass? It is defined as the ratio of mass of an atom of an element as compared to 1/12 mass of one atom of a carbon-12. So, how do we define the relative atomic mass? RAM. This will be equal to mass of one atom of an element. It is defined as mass of one atom of an element as compared to 1/12 mass of one atom of a carbon-12. As compared to 1/12 mass of 1/12 mass of one atom of carbon-12 as compared to 1/12 mass of one atom of a carbon-12. So, how do we define relative atomic mass? mass of one atom of an element as compared to 1 by 12th mass of one atom of a carbon-12. A point to be noted, mass of one atom of an element means what is an important thing. First of all, let me explain to you something before I proceed to explain the relative atomic mass. I have written over here as compared to 1 by 12th mass of one atom of a carbon-12. What do I mean by this? Students, if I say mass of carbon is 12 gram, whenever the atomic masses are expressed in gram, if I say mass of a carbon is 12 gram, it means it is a mass of 6.02 into 10 raised to power 23 atom. Am I clear? Whenever the masses are expressed in grams, it means it is a mass of 6.02 into 10 raised to power 23 atoms. So I will say over here 6.02 into 10 raised to power 23 atoms of carbon. It has a mass which will be equal to 12 gram. Am I clear? Whenever the mass of carbon is expressed in gram, that is a 12 gram, by experimental observation, it is observed that it is a mass of 6.02 into 10 raised to power 23, which can also be proved mathematically. If the time comes, I will definitely prove that. 6.02 into 10 raised to power 23 atoms of a carbon has what mass? 12 gram. So if I take mass of one atom of carbon, it will have what mass? This will be 12 upon 6.02 into 10 raised to power 23. Am I clear? And if you solve it up, it will come out to be equal to 1.99 into 10 raised to power minus 23 gram. It is the mass of how many atom of carbon? 1. Now if I find out 1 by 12th mass of one atom of carbon 12, 1 by 12th mass of one atom of carbon 12. This will be equal to 1.99 into 10 raised to power minus 23 divided by 12. We'll solve it up. It will be equal to 1.66 into 10 raised to power minus 24 gram. So what is a mass of 1 by 12th mass of carbon 12? 1 by 12th the mass of one atom of carbon 12 comes to be equal to 1.66 into 10 raised to power minus 24. Remember, this 1 by 12th mass of one atom of a carbon 12, this is 1 AMU. So you must have heard the word atomic mass unit. AMU stands for what? This is atomic mass unit. So atomic mass unit, if it is to be converted into gram, it will be equal to 1.66 into 10 raised to power minus 24 gram. What was the relative atomic mass? It is mass of one atom of an element as compared to 1 by 12th mass of one atom of a carbon 12. When I say 1 by 12th mass of one atom of a carbon 12, I mean to say the atomic mass unit. If I want to convert atomic mass unit into gram, how will I convert atomic mass unit into gram? By multiplying with 1.66 into 10 raised to power minus 24. Am I clear? See over here, student. Suppose we write down hydrogen mass is 1.008 AMU. Whenever the mass are expressed in AMU, it is the mass of one atom of an element. If I want to express the mass of one atom of an element in a gram, it is to be converted into gram by multiplying with 1.66 into 10 raised to power minus 24 gram. So 1.008 AMU is the mass of one atom of an element. It is the mass of one atom of an element. Now if I write down the mass of hydrogen is 1.008 into 1.66 into 10 raised to power minus 24 gram. This will be 1.008 into 1.66 into 10 raised to power minus 24 gram. This is the mass of one atom in gram. Or how would I have done this? The easier way would have been 6.02 into 10 raised to power 23 atom of hydrogen. It would have what mass? It would have a mass 1.008 gram. This was a mass of 6.02 into 10 raised to power 23 atom. If I would have find out the mass of one atom, it would have been 1.008 in upon 6.02 into 10 raised to power 23. On solving, this will come to be same. Am I getting clear? So how do I define relative atomic mass? It is the mass of one atom of an element as compared to 1 by 12th mass of one atom of a carbon-12. Now listen very carefully, student. What have I written over here? Mass of one atom of an element. As per the definition, it is written as mass of one atom of an element. But to be very precise, it is actually the average mass of all the isotopes of an element. If we take the isotopes of an element available in the nature, we find out their average mass on the basis of a percentage abundance. That average atomic mass of an atom of an element is how many times heavier as compared to 1 by 12th mass of one atom of a carbon-12 will be called as its relative atomic mass unit. See on the board very carefully. If I say we have got the two isotopes of chlorine, 17 chlorine 35, and then we have 17 chlorine 37. The percentage abundance of 17 chlorine 35 in the nature is 75% and the percentage abundance of this is 25%. Am I clear? How do I find out the average mass over here? Average mass of this element. This will be 75% of 35 plus 25% of 37. If I solve it up, it will come to be equal to 75 upon 100 into 35 plus 25 upon 100 into 37. On solving it out, it will come out to be equal to 35.5 atomic mass unit. Is it clear? It will come out to be equal to 35.5 atomic mass unit. Now this is the average mass of one atom of a chlorine. The average mass of one atom of a chlorine is how many times heavier as compared to 1 by 12th mass of one atom of a carbon-12 is actually the relative atomic mass. Am I clear? Although in the definition it will always be written as mass of one atom of an element as compared to 1 by 12th mass of one atom of a carbon-12. But actually how do we find it up? It is the average mass of an atom of an element. As for example in the case of a chlorine, what is the average mass coming? 35.5 atomic mass unit. So if I say the mass of chlorine is 35.5 ANU, how do I perceive this as a relative atomic number? It means first of all I will find out the average mass of all the isotope of a chlorine on the basis of a percentage abundance. Then whatever the answer comes, how many times that mass is heavier than 1 by 12th mass of one atom of a carbon-12 will be called as its relative atomic mass. And since it is a comparison with 1 by 12th mass of one atom of a carbon-12, that is why the unit will be written as over here as atomic mass unit. Actually, what is atomic mass unit? It is 1 by 12th mass of one atom of a carbon-12. There can be another way out, a student. Instead of this percentage abundance, in some of the question, the proportion ratio may be given. As for example over here, if we say this one, in the proportion ratio, if you take this over here, that we take 17 chlorine 35 and then we find out the proportion ratio. Suppose we have 17 chlorine 35 and then 17 chlorine 37. Suppose the proportion ratio of this is 3 and this ratio is 1. So this will be what? 3 into 35 plus 1 into 37 divided by 4, and this will come out to be equal to 35.5 atomic mass. So this again is the average mass of an isotopes of atom of chlorine, the percentage abundance either will be given or the proportion ratio will be given. In either case, we may find out the average mass, and how many times the average mass of an atom of an element is heavier than 1 by 12 mass of one atom of a carbon 12. That will be called as its relative atomic mass. Am I getting clear, student? Yes or not? So, define relative atomic mass. It is the ratio of the mass of one atom of an element as compared to 1 by 12 mass of one atom of a carbon 12. How do we obtain the mass of one atom of an element? By taking into consideration the average atomic mass of all the isotopes of an element present in the nature. Is it clear? Either on the basis of their fractional abundance or on the basis of their proportion ratio. That will give us a mass which is called as a relative atomic mass of an element. 1 by 12 mass of one atom of a carbon 12 is called as what? It is called as a atomic mass unit. Am I clear? Yes or no? Fine. Now just look over here. If I say mass of sodium is 23 AMU, it is a mass of how many atoms of sodium? 1. Mass of one atom of sodium will be 23 AMU. If I say sodium atom is 23 gram, it is the mass of how many atoms of sodium? 6.02 into 10 raised to power 23. Am I clear? If the mass of one atom of sodium is to be expressed in gram, how will I express? This will be 23 into 1.66 into 10 raised to power minus 24 gram. Is it getting clear? There is a point of difference. If the mass is directly expressed as 23 gram, it becomes a mass of 6.02 into 10 raised to power 23 atoms. And mass of so many number of atoms which were responsible for 12 gram of carbon 12, which actually was what? 6.02 into 10 raised to power 23. That is called as the gram atomic mass. So, gram atomic mass. Gram atomic mass. If I ask you to define or explain gram atomic mass, so how do I explain the gram atomic mass? Gram atomic mass. Gram atomic mass. Very simple. Atomic mass is expressed in gram, is a gram atomic mass. But what does this line mean? It means it is the mass of it is the mass of same number of atoms which are responsible for 6.02 into 10 raised to power 23 atoms of a carbon. Am I clear? That was what mass? 12 gram. That is called as a gram atomic mass. So how do I define the gram atomic mass? The amount of a substance. That amount of substance that contains same number of particles as were present in 12 gram of a carbon 12 is called as a gram atomic mass. Am I clear? Or in a very simple language, atomic mass of a substance expressed in a gram is called as a gram atomic mass. But what does this line mean? It means it is the same amount which contains 6.02 into 10 raised to power 23 particles as were present in the 12 gram of a carbon 12. Is it clear? So the amount of substance which contains the same number of particles as were present in 12 gram of a carbon 12 is called as a gram atomic mass. Or in the simple language, atomic mass of a substance expressed in gram is called as a gram atomic mass. So the amount of substance, which contains same number of particles, amount of substance which contains same number of particles as were present in 12 gram of carbon 12. 12 gram of carbon 12 is called as the gram atomic mass, or atomic mass expressed in gram, or atomic mass expressed in grams is called gram atomic mass. Atomic mass expressed in grams scored as the gram atomic mass of the substance. And how many particles were responsible for 12 gram of carbon 12? 6.02 into 10 raised to power 23. If any masses are directly expressed in gram, it is a mass of 6.02 into 10 raised to power 23. If a mass is expressed in AMU, it is a mass of one atom. If it is to be converted into gram, then it is to be multiplied by 1.66 into 10 raised to power minus 24 gram. So student, today I have tried to explain to you the relative atomic mass and gram atomic mass and recapitulated the class 8th work with you, which was the Dalton's atomic theory. I hope you must have understood this. In our next lecture, we will be discussing with you the molecular mass or the relative molecular mass and the gram molecular mass, and then we move to the Avogadro's law and the mole concept. Am I getting clear, student? I hope you must have been understanding the chemistry well. Please make the notes of this. The time is very tough for all of us. This is the best way then to teach you, that is a virtual mode of teaching. Please keep on studying hard, make the notes, try to solve the problems given in the book. With that, I'll say we'll meet again in the next lecture. Till then, thank you.